Hi, welcome to the 16th webinar in 12D's Industry Solutions webinar series. My name is Lisa Stewart, and I'm the Marketing and Communications Coordinator at 12D Solutions. Our Industry Solutions webinars are designed to provide insights into overcoming challenges in an evolving industry in more effective and efficient ways. We'll continue to run these webinars regularly and record them for posting on our YouTube channel and website. Our first 15 webinars from this Industry Solutions series, as well as the first 10 webinars from our training series, are available online if you missed those. During this live presentation, you'll be able to type your questions along the way, and we'll answer as many as possible throughout the webinar. At the end, I'll also read out some of your questions to the presenters if there's time. Today's webinar is something a little different. It's a case study which was presented at our 12D International Conference in July about data management and tunnelling. It will be presented by Matthew Monk and David Mares, representatives from the NorthConnex project. NorthConnex is a motorway tunnel link between the Hills M2 Motorway and the M1 Pacific Motorway. It has two key components, tunnel and M2 integration. It's Australia's longest and deepest road tunnel, longer than the Eastern Distributor, M5 East and cross-city tunnels combined. Over to you.
All right. Well, welcome. Thanks for your time today. I'd like to go through our case study of the NorthConnex project and how we've dealt with and overcome some of the issues associated with the project. So what we thought is we might go through a bit of, what is the project about at the start. So as mentioned, it's a motorway link between the M2 and the M1 motorways. And it's a very long and deep tunnel. As Lisa mentioned, longer than the Eastern Distributor, M5 and cross-city tunnels all combined. Project is being delivered by delivery partners Lend Lease and Bouygues Construction Australia for our clients Transurban, and supported by RMS and the New South Wales and federal governments. You can see on the screen the green area there is where we're joining the two motorways, and it creates the critical link. A little bit of an idea of what the project's about. 16 kilometres of mainline tunnels, 4 kilometres of ramps, 75 cross passages, 19 road headers. That's the big one there. That's more than's ever been mobilised at one time on a project. So it's a big one. All right. So our tunnelling, we've got generally 4 shaft areas. The shafts are sunk before we commence any tunnelling, and we're tunnelling using road headers. We've got some milestones of the project. We're looking at roughly mid-2016 is when we commence tunnelling. The project's due to complete in late 2019. All sorts of construction work to happen in between. So here are our challenges.
Okay, so some of the main challenges on this project is simply the fact it's a mega project. It's a large scale, and with that brings various program pressures. We also have problems associated with those, so consistency of systems across the project. Trying to standardise the skills with a diverse workforce and the methods. Managing the large amount of data that surveying on this project brings, and also your typical interfaces with third parties. Okay, and one of the big ones is the availability of suitably qualified and trained personnel.
Okay, so early on we took the decision we were going to try and use a lean approach. We got forced into this, really. Automate as much as possible, and uncouple administrative process from production roles as much as possible. So we set about having a plan. We created an instrumentation and software plan, and we tried to structure our data where formerly there was unstructured data. So here we are. Number 2 there, standardisation and centralisation. We'll talk a bit more about our centralisation of data models in a second. We looked at how we could create project-specific systems to assist us with efficiency. Data management goes without saying, and a big one also there, we're documenting as much training material and rolling this out as possible along the way. This is the instrumentation and software plan that we came up with. Now we've opted for a single platform sensor, so we've got the Leica TS16s and we've got the MS50s for our scanning purposes. We're also running with single platform Windows 7 on Panasonic ToughPads and exclusively running 12D model in the field and in the tunnel, and using 12D Synergy as our data management platform.
Okay, so part of the problem is how we structure all this field data that's coming in. So we need to make this as structured and straightforward as possible, and also allows us to automate it. So we separate our data coming in from the field by location. We also separate it by state, so what sort of survey it actually is. Okay, the current user's login also gets assigned, so we can track who does what. The current date and time, obviously, and all of this information is used to automate the naming of these field files, and this is done automatically, so the user doesn't have to remember or name them themselves. And all this leads to field data that is unique across the project and is also traceable, so we can actually trace it back to its source. We also have structured design data, so that means the source details are attached to all our design data, so the drawing number, the status and the revision from which the design data is derived. We've also done logical model naming to make grouping easier. And all this design data is read-only for the field surveys, so we don't have them accidentally or deliberately altering critical design data. So I'll now talk about the design aspect of this project. So some of the challenges. We don't have a 3D tunnel model. Okay, we only get road strings from our designer, and unfortunately they're from MX. So the data is not natively 12D field friendly. There's a bit of massaging we need to do. As with any design and construct environment, there are frequent just-in-time design changes. So we need to be flexible in how we handle those and respond to those. And we also have the typical interface challenges between various parts and phases of the project. So how do we model tunnels? The old PRO-PRA method is not being used on this project. Okay, in version 11, 12D added tri-meshes and snippets, and so we're relying heavily on these newer modelling methods. Version 12, our tunnelling modelling wouldn't have been possible without this snippet from profile. Effectively, you draw the profile in plan, and this little routine automatically creates a snippet of the tunnel. So we start off with something that looks like this. Okay, this is the sort of drawing we get from our designers. Just a PDF. Okay, 2D, dumb PDF, with just the basic information. We then have to draw this in 12D. Okay, and so we draw this in plan view. And we give it certain naming, so 12D can interpret all the various segments. This is just a superstring, and build its snippet. Okay, we then pass this string into this snippets from profiles panel. You can see there you give it the profile and a snippet, and it creates it. Okay, here's a screenshot of the snippet for anyone who's interested. You can see it's just a lot of links. Okay, so for a typical tunnel profile, you could have 50 to 100 links around the profile. So we are using mostly standard MTF commands. It's not that hard. One of the important parts is stretching heights, so we get a true perpendicular to the control line tunnel. We're also able to use layers, okay, and we can use various layers for rock, various layers of shotcrete or structural support, benching, structures, and so on. And using the MTF allows us to also modify the tunnel without creating additional profiles. Okay, just using your standard modifier commands. Okay, so for example, things like jet fans, egress or cross passages, and the tricky areas like junctions. So here's a screenshot just of a typical MTF for this project. There's only really 3 steps to modelling a tunnel. Snippet, stretch heights, create your shape. It's really that simple, just repeat it over and over. So with the shapes, we're using some of the new features. We can have varying lengths. So what this means is that you can have your profiles change. Okay? So long as your start and end link are constant and always present, the number of links can, in between those, can disappear, reappear, and 12D will do some smart, intelligent stitching and transitioning. Okay, so we'll stitch it together all nicely. Okay, we've also got a simpler syntax, so rather than having to type in 100 links when you're creating a shape, there's a bit of a shorthand there that just makes it a bit quicker. So here's just some screenshots I'll go through showing things we've modelled already. So this one shows the various layers, yellow, red, purple, of various layers of our tunnel, and the white tubes around the top are actually structural supports and canopy tubes. Okay, this next one is, I guess, showing a bit more, showing some of our overlapping tunnels and varying changes in profile, and also modelling the shafts and all the structural support there. And the good thing is, with this is not just pretty pictures. Pretty pictures is just one of the outputs of it. But all of this can be used directly in the field. So users can directly set out every bit of information you see on screen there. So again, here's just a close-up of a typical shaft with lots of, piles, capping beams, and rock bolts and anchors. That's all fairly standard things, just 3D strings in 12D. So how do we manage the model? All our control alignments, everything's dependent on control alignments. So we make sure they're versioned, so we can tell how things have been set out and whether people are using out-of-date information, and we also verify the geometry. We do this using our custom reports, and we put this into a spreadsheet that just highlights any discrepancies between our design and the design we get from our designers. Okay, tunnel definitions as well. So new in version 12, we can now attach tunnel definitions directly to the center line. Okay, previously they had to be separate files. That just became too much to manage. Okay, so now we can set these, and these are just stored as attributes on the control line. Okay, we also have a central data model, which we'll go through in a bit more detail later on. It's centralized, restricted, version controlled with 12D synergy, and we actually automatically push this out to surveyors. So, what are some of the successes we've had through using 12D? We can quickly and easily model tunnels. Okay? The use of MTFs and snippets allows us to produce a very flexible 3D model very quickly. Okay? The versatility of tri-meshes also means we can model a lot of different objects. Okay? We can use them for tunnels, for structural elements, for roads, for pavements, for pretty much anything we want on our project. Okay? And the use of 12D obviously takes some dumb data and makes it a bit more smart. okay, with things like attributes. Okay, I'll now pass on to Dave, who will discuss the surveying and construction aspects.
Okay, thanks, Matt. Look, we've been through some of the scale and scope of the project as far as the challenges go. We talked about having a record number of road headers concurrently working. Multiple concurrent work fronts are very difficult to manage. We're heavily controlled on specification and compliance to QA. As anyone in the industry knows at the moment, it's very difficult to attract staff. There is not enough staff to go around, and with a blended team, you might have various different subcontractors. Everyone has their own method of doing something, their own code lists, for instance, and we want to standardise that. All right, so I think we've got a screenshot of some tunnelling work here. This is some completed tunnels from down the southern area of NorthConnex. What you see on the left-hand side is road header in action, and that's on the left-hand side. And on the right-hand side, I think what we've got down there is some shock grading happening. Okay, as you may have been able to tell, space is very limited. Access is difficult. It provides a very challenging work environment. Another thing to consider is when we're pushing data to and from our field surveyors, is they're often working in a disconnected or offline environment. We need to be able to give them information to be able to make key decisions on site when required. So, at the start of the project, we sort of sat down and said, look at all these challenges, and we knew we had to develop some better systems to standardise all this. Once we made the decision we were going with 12D systems, we knew that we had to create a customisation specific for the project, just to bring together all the elements, standardise all the field naming and file naming, etc., etc. We wanted to automate as much as possible, including things like naming of field files, and we wanted to streamline the reporting process, make that not so much of a pain. One other aspect, which is pretty large, is to collect all of our information and store it in one place, make sure it's backed up, and so we can meet our QA standards. So we created a 12D customisation. Now we've got separate ones for office users and field users, and as I said before, it standardised our coding. This happened kind of overnight. It was optimised our field functions. Now what we did is separated them out and created large usable buttons, if you like, for 12D field use. And another thing we did is we created some specific macros that were able to automate a lot of the data management process.
Okay, so one of these, probably the most critical macro that we wrote was our submit fieldwork. So every time a user does some survey, they submit their fieldwork. And this macro does various things. It performs various QA checks, and this is done automatically in the background. It does various checks such as against our G71, which is the road RMS specification. It checks things like, was it recently calibrated? It also assigns a QA quality class, a shorthand for all that information. It checks whether the data has already been submitted, so we're not getting duplicated data in our central model. And all this allows us to ensure consistent QA standards, ensure our surveyors are surveying to appropriate standards, they can easily see it, and if they're if they don't meet those standards, then it allows for remedial action whilst they're in the field. Okay, as part of this process, it adds all these attributes to the data. Okay, it exports this data for upload, and this is exported locally to the tablet, so it's offline and synced later. It's also standardized naming, and there are various outputs depending on the data and how we need to interface with other software packages. So I'll show, this is just a screenshot of this macro, and you'll see that it's quite simple, and we've used a traffic light system. Green is good, red is bad, yellow is maybe something wrong. And there's really only 2-3 things to select there. The model, type of comment, and hit the button. That's pretty much it. All the other things are standard, the naming convention, the directory it goes into, all that's taken care of, so it just means it's a lot easier for our surveyors. So that takes care of our fieldwork data. Okay. We also need to take care of other data. So other data is data that's been post-processed, so edited or slightly modified. Calcs data, so data that you might be setting out, plots, reports, and so on. Okay, and so this is important because it allows for post-processing and edits. It also allows the surveyor to take ownership of their data, okay, to ensure that it's correct and something they can actually own. And it also allows for review and/or just storage. Okay, so here's a screenshot of that macro. Again, the amount of fields they fill out will vary depending on what sort of data they're submitting, but it's all designed to be nice and easy, and in particular very touchscreen friendly. Lots of drop downs and not so much typing. Okay, another one. So this is more on the office side of things. We have an approved data macro. Okay, so once they submitted their data, we get to view the QA report. So we can again check whether it's passed, check if there's anything, surveying practices that they may not be doing correctly. It allows us to map and approve data. Okay, so map it into standard models, the approval, and it also updates the 12D synergy status. So we've got an attribute in synergy that tracks whether it's approved, rejected, or pending review. So we can easily search for such files. Okay, and this is added as an attribute and also as a new version. So there's a screenshot of the macro. Again, not a lot to it, but it just speeds up the whole process, and it's another step in our QA. So, some of the successes we've had through using 12D on this project. We have got rich data collected in the field. Any surveyors who've looked at the attributes collected by 12D field will know how much data is attached to that survey, and we're using that for our QA processes. We can report on that, we can extract all sorts of information. There's minimal post-processing, so if we set up our systems, our procedures right, then there really isn't a lot of office work to be done, which means the surveyors can spend more time in the field. Okay? They can produce outputs in the field. Again, it's just about making surveyors more productive. Okay? And we can analyse this data using macros. Okay? And as a result, we've been able to significantly reduce the burden on our surveyors. They don't have to remember obscure naming conventions. They click the button and it happens for them. So now I'll hand over to Dave, who'll talk about data management.
Okay, thanks, Matt. All right, so these challenges we've spoken about before. However, when you think about tunnelling, we've got approximately between 4,000 and 5,000 cuts. Now, what that means is advancements, if you like. Now, that is a hell of a lot. We've got between 5 and 10 survey tasks per surveyor per day. That's what we estimate the the work rate to be, and we're operating in a 24 hours a day, 7 day a week operation. Using our scanning, approximately 100 million scan points per lining, of which we have 3. So there's a lot of data to manage. Also, we've got around about 300,000 rock bolts to place. If we were to do conformances at every 1 metre interval, it's around about 100,000 plots, and that assumes that we only plot these once, which is really the case. Okay, so more on the challenges. Previous techniques are highly manual, often require a lot of office work. The data produced is often highly unstructured and difficult to manage. I think, there's an outdated data culture within the profession, and we need to operate in offline and online modes, which has to be considered. Okay, so our central data model. This is a concept that's not really a new thing. It's an old concept, but it's rarely used and it's difficult to implement. This is where all data is centralised, and that's the model that we've opted for. Design and historical data is sent out to our surveyors, and new data is retrieved. So, as surveyors, or field surveyors, we consume information, but we also produce it. By having a CDM, we've got one source of truth, and a benefit is that we can produce a live as-built model. That live as-built model is shared out to our field surveyors and also to other functional areas. Here's a screenshot showing our central data model. These are some of the inputs and also some of the outputs. As you can see, centralised, it's controlled, it's well backed up, and all the data is tracked. Okay, so in the collection of data, the data produced, most focus has been on structuring field work. We're also focusing on structuring outputs such as plots and reports, and not too far away from encompassing all data on the project, which includes photos and notes and all sorts of other things. So the data that's consumed by the field surveyors is distributed. It's heavily reliant on 12D sharing. It's read-only for the user. We have subscription files, which makes things a lot easier. We use non-synergy sharing because we're due to the offline nature of the way we're working. And we use a custom macro in order to do this. So it's very difficult to right-click and select a folder location on a tablet with a stylus. So we've got a custom macro which allows us to use checkboxes and these sort of things to make them touch-friendly. As far as sharing subscriptions go, this is our master share files subscription tab, the one I just mentioned. And as you can see, it's full of checkboxes. This is all about usability in the field. The user can select what he needs, press process, and the data will appear. The back end is similar to a screen that most 12D sharing users would know. The front panel fills out the second panel here, files, and the process will allow that execution.
Okay, so now I'll talk about file synchronization. So we've got all this data coming in from the field, and we've got all this data we need to send out to the field. So we've got uploads and downloads. Okay, so we initially tried some third-party sync software we found on the internet, and it worked well enough, but we soon ran into some problems. And we saw that maybe this wasn't going to work long term. So we discussed these problems with 12D. They're great to approach, and they're very easy to suggest and bounce ideas off. And we needed something that was simple but reliable, rock solid. And so what the lovely guys at 12D did is they actually helped develop a custom solution for us. It is technically called 12D Synergy Synchronization Tool, but that's a bit of a mouthful, so we've nicknamed it Synchrony. Okay, a lot snappier. So the Synergy Sync tool, Synchrony, it's based on the 12D Synergy client. Okay, it doesn't really require any special knowledge or training. It is centrally managed and task-based, so we get to benefit from all the Synergy task processes like tracking progress, closing, due dates, and so on. We can also upload and download, and these can be done either manually, so on demand, and also automatic. So if the user coincides, we can schedule it every hour or a particular interval. And again, this works well with the whole offline online. We never know when the user is going to actually be connected to the network. So here's some screenshots. So basically what we have is we have the tasks in the top right. So this is in the Synergy client. So this is in the office. We generally create this data to push out. On the client, so the field surveyor's tablet in the top left there, there's a little Synergy sitting there in the system tray. Little icon there. And that's this sync tool that's running all the time. Okay, when data is available to download, a little pop-up appears, like in the bottom left, and you get a description, what's changed, why you might want to download it. You've got two options, yes or no, but if you click no, it'll simply keep pestering you. Okay, so you can actually force data always out, so users don't get an option not to download data. So as mentioned previously, the fieldwork that's processed for review is also tracked via Synergy. So all this data that's coming in is uploaded to Synergy. It's tracked with attributes both in 12D model and in Synergy, and we actually have a full audit trail on 12D model data. Okay, these attributes are added at each stage. Who processed it, who approved it, what time and date, which computer it was done from, and notes and so on. So what this allows us to do is that in our survey model, every single point in our central data model can actually be traced back to the original user, time, file, even instrument, and so on. Very important for meeting our QA requirements. So I'll just show some screenshots. These are taken directly from our live as-built model, so these are directly from our central data models. Okay, so these just grow over time as users submit fieldwork, and also we approve it and import it into our central data model. Okay, here's a nice one showing our as-built model on the left, so what's actually been built and picked up, versus our design model on the right. So you can see that they're pretty much spot on as you'd hope and expect, and we can actually do various reports and conformance checks on those. So what are some of the successes we've had? We get automated data submission. We can do collection of data, and it doesn't matter whether they're offline or online, which is a big improvement on this project. Importantly, by automating some of these processes, we get structured data. So all data from anyone on this project is the same, and it's usable. Okay, we don't spend hours massaging or editing. It's immediately usable. Okay, and importantly, when we feed this back through our central data model and back out to our field surveyors, all the survey staff are using the same base data. We don't have to worry about someone using out-of-date information. We can see that it's all up to date with Synergy. Okay? The data is current, controlled, and live. It's a dynamic model. We're not building this at the end of the project, just when we have to. We're building it as we go along. I'll now hand over to Dave, who will talk about some of the interfaces and outputs we'll have.
Okay, thanks, Matt. All right, so a few more challenges for us. This data that which we speak, it's relied upon by others, other functional areas, including other areas within our survey department, if you like. Guidance and machine control is a very big one. Monitoring, deformation monitoring, and the collection of data as an input for this is a big one. Utilities, geotechs, these are all forms of data that's relied upon by others. Another challenge is to be able to produce and use reports at the work front. So with our road headers, we've got an interface with Geodata, who are the providers of a guidance system. We need to provide profiles and also alignments. Now these originate within 12D. Also, we've got another interface also through Geodata for our rock bolting solution. These also need bolt locations to be calculated, alignments to be produced, and again, this happens through 12D. For our surface works, we've also got standard sort of graders and pavers using strings and tins, again developed within 12D and pushed out. As far as monitoring, we've got our monitoring points are controlled within our central data model. As far as our monitoring surveys, this is something that happens multiple times every day. It's managed through Synergy. We have data that's synchronised out from our central data model, used in the field, and uploaded back into Synergy for processing. At that point, it's copied out to a external server where it's harvested and placed into a program known as Kronos. This process is critical. It is a production critical process in order to get a permit to carry out tunnelling the next day. Okay, so what you can see on the screen is also a tunnel conformance report. Now we've got the ability to be able to produce this on demand. This can be produced from the tablet on site. Now that's of course a fictional report. Rock bolt conformance. This is a difficult thing to manage because we're dealing in a non 2D environment, of course, with 3D shapes. Now, through the use of the ability for us to unwrap a tunnel to a 2D state, we're able to now produce rock bolts conformances like you see on your screen now. Now, this is a custom macro that Matthew wrote. It colours the lines that you can see there according to a pass-fail criteria. Again, this is sample data. Another innovation is some heat mapping. Now, we use the term heat mapping. They're not actually heat maps, really. What they are is thickness maps, I guess. This is a process where we need to use a transformation. Okay, so a 3D transformation to a 2D. In order to get plane coordinates. Now, if we do that with two surfaces, then it's the comparison of those two surfaces that we're after. We're able to then contour, colour, and then rewrap that figure back into a 3D solid. And this is the result. I think you'll agree. It's a very good deliverable. Now, there's various criteria that you can apply. In terms of thicknesses, add colours or whatever you like. It's fully customizable.
And of course, once you've rewrapped it into 3D space, you can then actually set this information out. So you can trace it with your instrument laser on site in the tunnel and show your operator where they actually need to excavate. So it's a very powerful tool. We're only really scratching the surface with this one, but hoping to use it a lot more.
Okay, so the successes that we've been able to manage through the use of 12D software, we've automated outputs to others, for instance, guidance and monitoring, eliminated as much as possible double handling of data. This is wasted time. We're able to make better, more informed engineering decisions in the field, and of course, less time in the office.
Okay, so now I'll just talk about some of the conclusions and I guess some of the benefits of our partnership with 12D. So we have been able to develop what we consider industry-leading systems. These are not things that are typically done in the past. Even on tunnel projects, I think these are new, innovative solutions. We've been able to provide an integrated solution, okay, with 12D model and 12D synergy working so well together, okay. But at the same time, it's also flexible and customizable. None of this would have been possible without being able to write our own macros, customize the interface, customize reporting and plots to the extent that we can with 12D model and 12D synergy. We also have easier analysis because we've got such rich data. Okay, they're not just dumb 3D strings we're getting all the attributes with it, and allows us to make better, more informed decisions and analyse things with greater ease and more easily. It also allows us to do more work at the work face. Okay. It's also easier to detect clashes, not just utility clashes, but clashes between, all these things that are happening. You've got bolts going in, tunnels and shafts going in all sorts of directions. And by modelling these in 3D, we can actually identify them and flag them as problems before they become problems on site. And we've also greatly reduced the dependence on manual processes, and that just flows into natural time savings. So, what is the future for this project? We hope to expand the automation of processes, further real-time reporting from the field, improving our management of data. So we're doing a lot, but there's still a lot of improvements we can make. Using some of this data to provide data-driven solutions. Okay? And we also have numerous tunnel projects on the horizon, which hopefully we'll be able to adapt and take all the lessons we've developed here and use those on future projects. Thank you for your time.
Thank you.
Over to you, Lisa.
Thanks, guys. I think we're running a little close to time, so I'm not going to do any live questions today, but we can always get back to people later if people need their questions answered. The recording of this webinar will be available in coming days through our website and our YouTube channel. We've got plenty more great webinar topics lined up in coming weeks, and we'll keep updating the website with more topics as they're set, and also keep you posted through email and social media, so do stay tuned. If you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you for attending, and we hope to see you at future webinars.